All right, pre-algebra. So today we're doing a big review. We're doing a review of two-dimensional shapes. So we're going to find the area of two-dimensional shapes. This is going to take 2 pages just because the flip books that we're putting in here take up so much space. We wanted to have a lot of room. So this is going to go on 2 pages. So before you start watching this video, make sure you cut out all of those things just so that you're ready to go as we go along. So pause this video as needed right now so that you can get those cut out and then get ready to copy along notes with us. So two-dimensional shapes are 2D shapes, right? That's the abbreviation for two-dimensional. 2D means two-dimensional. And dimensions, if you've ever gone, to IKEA or Walmart or Target and purchased like some furniture that you needed to put together, it tells you the dimensions. It tells you how tall it is, or it tells you how wide it is, or how long it is, right? Dimensions are measurements. So two-dimensional shapes have 2 measurements. Now, those measurements, it's confusing. Is it the height, or is it the width, or is it the length, right? Those words sometimes bog us down. So all you really need to remember is that it must have a base and a height. Right? I think sometimes in elementary school we learn, an area is length times width. Well, nothing else really has a length and a width, but everything has a base, which is a fancy word for the bottom of something, and a height, how tall it is. You can easily measure that. So we're going to talk about these, and you may already know formulas, and your formulas that you already know are perfect. They work. I'm just going to change the wording from length and width and all of that stuff to base and to height. So just so that you're aware, some synonyms. Right? Synonyms means the same. Synonyms for height would be, sometimes you say length, sometimes it's width, sometimes we say altitude. All you need to know is that height is whatever goes up and down. Height is up and down, vertical. Sometimes, synonyms for base could be length, could be width, could be bottom, could just be side. You know that the base is from side to side. It's the bottom of the shape. It's what it rests on. I think if we could go back in time, I would wish that I could just change all of those formulas way back when they were first put into schools, and change it so that everybody just called it base, called it height. We're going to start with square. That's probably the easiest one that everyone remembers. I'm going to glue these down in a second, but it's easier sometimes to write on them when they're not glued into our book. So I'm going to put square here. So I'm going to open it up. Let's define what a square is, right? A square is a quadrilateral, means 4, where all sides are equal and all angles are 90 degrees. Sometimes it's shown like that. Those lines mean that they're all the same. The area formula is base times height. Now you could have heard it as side times side or even side squared. That's exactly the same as base times height. It's exactly the same. It's just the bottom, which in this one would be 4, and the height, which in this is 4. It's the bottom times how tall it is. The bottom times how tall it is. If you can find the base and you can find the height, you can find the area of anything. Base times height, which in this one would be 16 units squared, or square units. Area is squared. So I'm going to put this, glue it down. I'm using tape because I can't find my glue stick at home. There's one. Let's review a rectangle next. So I'm going to fold it again. Open it up. Rectangle, when defined, is a quadrilateral, which again means four-sided shape, with 2 sets of equal sides. This means the top equals the bottom and the left equals the right. And all 4 angles equal 90 degrees. So the top is equal to the bottom, and the left is equal to the right, and 90 degrees. The area formula, you probably know it as length times width. Now, sometimes that's really a struggle because students get really fixated on which one's the length and which one's the width. I don't know. But if you say base times height, meaning the bottom, which is 10, and the height, which is 3, can you find the area? Yeah. 10 times 3 is 30 units squared. Base times height. So I'm going to put this right here. Where'd my tape go? Oh, there it is. So again, we're not learning anything new in this. We're just reviewing. I think the new part might be the base and the height thing, just because you're used to sides and lengths and widths and all of that good stuff. But again, you just need to be able to find the base and find the height. So let's put that down here. Again, I get it. Length, width, side, all that stuff that you've learned before. But if you just find the base and find the height, you're good to go. All right, I'm going to turn to the next page because we have to put 4 more and they won't all fit on one page. So we're going to put it on the next page here. All right, let's go with parallelogram. Right, a parallelogram is a rectangle that's just tilted on its side. Right, it's just tilted a little bit, right? It's like something heavy was put on it and it leaned a little bit to the left or a little bit to the right. So parallelogram, let's define that. Again, is a quadrilateral, which is 4 sides. And it has 2 sets of equal sides. And again, this is the top equals the bottom, and the left equals the right. There's no angle measurements on here, right? They're not 90 degrees. If it was 90 degrees, it'd be a rectangle. This is just a little bit to the side. Looks like this. Or maybe it faces the other way. Right? It's just a quadrilateral. The bottom and the top, the left and the right. But there's no 90-degree angle. And you guys, here's the cool thing about quadrilaterals. I'm going to use a piece of paper to show you. If I had a quadrilateral or a parallelogram, right, and I cut off this piece just like this, and I took this and moved it over here, right, I take this piece right here and I cut it off and I move it over here, what shape does it make? It makes a rectangle, right? I mean, that's a rectangle. So a parallelogram is just a rectangle, but it's tilted to the side. The area formula is the same. It's the base times the height. So if this was 7 and this was 6, the area would be 7 times 6, so it would be 42 units squared. Base times height. If you remember that, you can find the area of everything. Base times height. On to trapezoid. Probably the most confusing quadrilateral of all. A trapezoid, let's use this color, again is a quadrilateral, which means four-sided, but it's completely different. A quadrilateral is different. It can have all four sides different lengths. It can have all kinds of craziness in it. So a quadrilateral is a four-sided shape. Now, a quadrilateral can look like this. A quadrilateral can look like this. Right? Quadrilaterals, they're a little bizarre. So because they're a little bizarre, I don't know which is the base and all of that stuff, right? I mean, like, it's crazy. What it does have is it has one set of parallel sides. And it's usually the top and the bottom, the top and the bottom. But what if my quadrilateral was drawn like this? Does it still have a set of parallel sides? This symbol, an arrow, shows that they're parallel. Yeah, it still does have parallel sides. So my struggle is the base, right? I have the base, I have a height, but which one's the base? Where's the height? So here's the issue. I don't know, is this the base or is this the base? Well, it's resting on this one, but what if I drew it upside down? What if I drew the big one on the bottom? That's the base. Or is that the base? I don't know. Is this one the base or is this one the base? So here's what you have to do. The parallel sides are your base. You don't want to rest your or your trapezoid on a tilted side, right? That looks ridiculous, right? If I drew it like this, that's crazy talk. You always want your parallel sides to be top and bottom. But the trick is you need the average of the parallel sides is the base. The average of the parallel sides is the base. That's the trick. Because the formula is not base times height. It's a little trickier because your base is the average of the parallel sides. How do you find the average of something? You add them up and divide by 2. So for a quadrilateral, you do base 1 plus base 2 divided by 2. Base 1 plus base 2 divided by 2 is your base. It's the average of the parallel sides. So the top plus the bottom, get an answer, divide by 2. Multiply that by your height. So you're finding the base, you're just finding the average of the base. Is the base the top or the bottom? I don't know. Is it the top or the bottom? I don't know. Because it could be drawn any way you wanted. Right? The parallelogram, if this is the bottom, even if you flipped it upside down, the bottom would be the same. Here, if I flipped this guy upside down, the bottom's a different length. So if this is 4 and this is 5, I'd do 4 plus 5 divided by 2. 4 plus 5 divided by 2, that's 9. Divided by 2 is 4.5. If this was 7 and this was 4, I'd do 7 plus 4 divided by 2. 7 plus 4 is 11. 11 divided by 2, my base is 5.5. If this was 13 and this was 11, I do 11 plus 13 divided by 2. 11 plus 13 is 24. 24 divided by 2 is 12. So to find the base, you have to find the average of the parallel sides. The height is usually shown, well, in this one, here's the height. If this was, what do you think, 3? I do 4.5 because that's the average of my bases times 3, which would be 13.5 units squared. On ones that look like this, they show you the height by a dotted line inside. If this was, what do you think, 4? You'd do 5.5 times 4, which would be 22 units squared. This one, what do you think? 10? So you do 12 because 11 plus 13, the top and bottom added together divided by 2, the average of the parallel sides is 12 times 10, 120 units squared. The trapezoid is far and away the hardest. All right, let's go to triangle. Let's get out of quadrilaterals. And let's go to triangle. So we have triangle. How many sides does the triangle have? Tri means 3. So a triangle is a 3-sided shape. There are all kinds of triangles out there. Let's talk a little bit, review about words. You can measure them by angles. So there are obtuse, meaning the biggest angle is obtuse. There's acute, meaning the biggest angle is acute. And there's right. If we talked about side lengths, we have something called equilateral, meaning all sides are equal. We have something called scalene, meaning all sides are different. And we have isosceles, meaning 2 sides are the same. Triangles can look different too. That's kind of an ugly triangle, but you know what I mean. There we go. Those are all triangles. They all work. The interesting thing about triangles, if I get another piece of paper, a triangle, if I doubled it, if I redrew that triangle and put them together, those triangles are the same. I mean, they're exactly the same. Just one's on top of the other. Two triangles make a rectangle. This triangle, if I make this into a rectangle, right? Not the most beautiful thing I've ever drawn, but watch this. I'm going to cut this out, right? Here's my triangle. I'm going to cut this piece and this piece out. If I can find my scissors. There they are. All right, so if I cut this out, you have nothing to watch. Sorry, this is kind of boring. Now again, my drawing's not the best you've ever seen in your entire life, but here's my triangle, right? And I drew a rectangle around it. If I cut... All right, here we go. Sorry, I paused it so that I could get this ready for you. So here's my rectangle, right? Here's my triangle, and I made a rectangle around it. If I cut those pieces off and I put them together, what does it make? It makes the same triangle, right? I have a triangle, and if I draw a rectangle around it, so a triangle is a rectangle, but not really, right? A triangle's inside a rectangle. Oh, wait, could I say that one triangle, if I double that triangle, it makes a rectangle? If I have a triangle and I double it, it makes a rectangle. So, okay, doubling something, doubling, that means multiplying by 2. So if I start with a triangle and I multiply it by 2, I get a rectangle. Okay, what if I start with a rectangle? I wonder how I'd get a triangle. What's the opposite, the inverse of doubling something? Dividing by 2, or multiplying by 1/2. So the area formula is base times height, because that's the rectangle, but I don't want a rectangle, I want a triangle, divided by 2. Or 1/2 base times height, because 1/2 and dividing by 2 are exactly the same thing. In this triangle, if my base is 4, they're going to show me my height inside it as 10. I'm going to do 10 times 4 divided by 2. 10 times 4, that would be a rectangle, is 40, but I don't want a rectangle, I want a triangle, so half of that is 20 units squared. This one, it shows you your height right here. It's nice and easy. So if that's 3 and this is 7, I'm going to do 3 times 7 divided by 2. Always dividing it by 2, base times height, but I don't want a rectangle. I don't want a quadrilateral. I want a triangle. A triangle is half the space of a rectangle. So 3 times 7 is 21. 21 divided by 2 is 10.5 units squared. This one's a little harder because this is 8 My height is not this side, right? That's at a diagonal. My height has to be straight up and down. And I have to kind of do it out to the side. So my height here, let's say, is 2. So this guy would be 8 times 2 divided by 2. 8 times 2 is 16. 16 divided by 2 is 8 units squared. So that's triangle. Let's get that in our notebook, and then we'll go to the completely oddball, which is circle. So put in triangle. Remember, you're gluing these down. I'm taping because I can't find my glue. Here comes circle. Hopefully at this point in time in the year, you have this memorized. Circle has no sides, right? It's perfectly round and beautiful and fantastic. A circle has 2 measurements. A circle has a radius, which is from the center to the edge, and it has a diameter, which is all the way across, but it has to be through the middle. I know I've shown you this picture before. If you have a circle, an easy way to remember what this looks like is R for radius is short and halfway. D for diameter is tall and all the way through. The area formula for a circle is pi r squared. We use 3.14 for pi. So if I have a circle and my radius is 2, right? I would do 3.14 times 2 squared. So this would be 3.14 times 2 squared. Your calculator is going to use correct order of operations, or you need to remember correct order of operations. 2 squared goes first. 2 times 2 is 4, and 4 times 3.14, which is pi, is 12.56 units squared. What if they give you the diameter? What if they said, here's your circle, and all the way across is 5? How would you find the area of that? You'd still do pi r squared. So you'd have to do 3.14 times, but what's my radius? If my diameter all the way across is 5, what would I use for my radius? Oh, well, half of 5 is 2.5 squared. Plug it into your calculator and you get your answer. Let's put this in our book. And you have reviewed area formulas. On your homework, you're really going to have to practice patience because you're going to have to count. Each square is half or 0.5 of a centimeter. So you're going to have to add, if you have 2 squares, that's 1 because it's 0.5 and 0.5. You're going to have to be careful counting your base and your height of every single shape.